Good afternoon, everyone, and welcome to
Good afternoon, sir.
this lecture. We were dealing with circular motion in the last class, and we had seen the terms that come in circular motion. We had seen angular position, angular displacement, average angular velocity. Do we remember all those terms? Instantaneous angular velocity, and you had seen when we have uniform circular motion. There are two terms in uniform circular motion. One is the time period, time taken to complete one cycle, and the other one is known as frequency. Do we all remember this? Yes or no? We remember this uniform circular motion, constant angular velocity. Yes or no? Everyone seems to be lost today. Are we there in the class? Okay, the mic seems not to be working. Anyways, now in today's class, last class we finished that uniform circular motion. So we can write the next heading, and the next heading would be non-uniform circular motion. I hope everyone can see this. Non-uniform circular motion. Now, what do you mean by a non-uniform circular motion? When do we say the circular motion is non-uniform? When the angular velocity, when angular velocity changes, angular velocity is not constant. If angular velocity, that is omega, it changes, we call that motion as non-uniform circular motion. You all understand this? Non-uniform circular motion. Now this angular velocity is going to change, and who is going to change this angular velocity? So we have the next term that is coming there, and the next term is known as average angular acceleration. Average angular acceleration. Now, how do you write this average angular acceleration? Alpha means angular acceleration is a vector, and it is in a box. This box means that this is average. What type of quantity is this average angular acceleration similar to? If you think about the linear motion, this average angular acceleration is similar to your average acceleration. Do we remember this average acceleration? Yes or no? So it is similar to, not exactly same, it is similar to, because what work this acceleration is doing in linear motion, the same work angular acceleration is doing in circular motion, or shall I say rotational motion. Rotation is a chapter which is going to come. There also we will see this same term. Now, as soon as we see this average angular acceleration, what would be average angular acceleration? So this will be equal to total change in angular velocity divided by total time. Total change in angular velocity divided by total time. That is your average angular acceleration. How will you write it? This average angular action vector wise will be omega 2 vector final angular velocity minus omega 1 vector divided by total time t. Why I'm saying that this is similar to the average acceleration that we had seen. If you remember, the average acceleration that we had seen vector wise, if I write, that was final velocity v minus initial velocity u divided by time. Do we remember this? Yes or no? So basically they are similar terms in those sense. What job acceleration does In linear motion, the same thing this does in angular motion or circular motion or rotational motion. Now, what is the SI unit of angular acceleration or average angular acceleration? It is omega divided by t. So SI unit becomes radians per second square. Rad per second square. Do we understand this? And the dimension becomes, remember, angle does not have any dimension, so it becomes t raised to the power of -2. That is your average angular acceleration. Now, as soon as we hear the term average, one thing should always strike us, that once we talk about average, the average value is always calculated over an interval of time. So this is calculated over an interval of time between A to B, T1 to T2, here to there. It is always calculated over an interval of time. It is always calculated over an interval of time. Do we understand this? Yes or no? It is always calculated over an interval of time. This was average angular acceleration. Now, this is calculated over an interval of time. This was your point or character number 5 that comes. What would be the next character? I hope everyone has written this down. What would be the next character that would come? Next character in this movie. So circular motion. What is the next character? After average angular acceleration, what is the next character?
Angular acceleration, sir.
Instantaneous. Angular acceleration. And how do we write this instantaneous angular acceleration? We write it like this. And what it should remind of instantaneous angular acceleration, it is doing similar job as your instantaneous acceleration was doing in your linear motion. So what do you mean by instantaneous angular acceleration? It means, what is the meaning of the term? It is the angular acceleration at any instant. If you are moving in a circular path, or if you are moving in rotational motion, and someone asks you, hey, what is your angular acceleration? Which acceleration are you going to tell? You're going to tell them your instantaneous angular acceleration. Yes or no? No, yes. Do we understand this? Now, as soon as you understand that this is instantaneous angular acceleration, you can also understand how we are going to write this. You will write it as d omega by dt. As soon as you write it as d omega by dt, it should remind you of how you had written the instantaneous acceleration. Instantaneous acceleration you had written as dv by dt. Yes or no? No or yes? Now, since you have written it like this, you can call it rate of change of angular velocity with time. Their acceleration, that linear acceleration, was rate of change of velocity with time. This is rate of change of angular velocity with time. Do we understand this? Yes or no? Instantaneous angular acceleration. Okay. Then now we can also understand the other two terms. I mean, this instantaneous angular acceleration, the SI unit will be radians per second square. No problems with that. The unit will also be same and the dimension will also be same. Yes or no? We understand this. Okay. Now we can understand these two terms as well. Constant or angular acceleration. What will you mean by constant angular acceleration? What would you mean by constant angular acceleration? When I say constant angular acceleration, this means your angular acceleration would remain same or it would remain constant. Do we understand this? So in this case, I can say very easily your instantaneous angular acceleration will be same as your average angular acceleration, which is equal to omega 2 minus omega 1 divided by t. Do we understand this? This is actually same as your case where the acceleration of the body was constant. We had seen the equations of motion with constant acceleration. We'll also see equations of motion with constant angular acceleration. But before going on to constant angular acceleration, then see the last term as well so that everything is then covered. So the last term here will be variable or non-uniform. Non-uniform or variable angular acceleration. Here what will happen? In variable or non-uniform angular acceleration, your angular acceleration will change with time. Do we understand this? Yes or no? Everyone understands this? Can I give you a question now? Remember, all the questions are based on simple facts. If you remember the definitions correctly, you should be able to solve them. Are you ready for the question? So this is the question coming for you. The angular velocity of a particle is given by omega is equal to 1.5t minus 3t square plus 2. At what time is angular acceleration becomes 0? At what time is angular acceleration becomes 0? Yes. Shall I do it?
Option B, sir.
Option B, 0.25 seconds. That is correct. How did you get it? So your omega is given to you, and you have to find out the time at which your angular acceleration becomes 0. Omega is given as 1.5 t minus 3t square plus 2. How do you find the angular acceleration? Alpha angular acceleration is d omega by d.
By differentiating, sir.
So we need to differentiate it, yes? And how do we differentiate it? It will become 1.5 minus 60. Yes or no? And this must be equal to 0. So from there, you can find out the value of t. T is 1.5 divided by 6, and that will come as 0.25 seconds. Anyone understand this? Yes or no? No or yes? Anyone got this answer? Okay. Let me give you another question. Everyone got this, so I can move on to the next question. Yes? This is the next question. I hope you can do it quickly so that we can move on to the other things quickly. The angular displacement of a flywheel varies with time as something given. What is the angular acceleration? How do you find the angular acceleration? I'll give you 2 minutes. Once you're done, please let me know.
Option D, sir.
Option B, sir.
E, sir.
Option D. Yes, option D is correct. How are you supposed to do it? Angular displacement or angular position is given as a function of time. What do? In first step, you first find out the angular velocity, you differentiate it once. So you get A plus 2B, A plus 2BT plus 3CT square. Then you have to find angular acceleration. You have to differentiate it once more. 2B plus 6CT, and that is your answer. Everyone understand this? Yes or no? No, yes. Okay. Shall we move on to the next thing? As you can see, whatever we are doing here is exactly similar to what we had done in the linear motion. The only thing is angular is added everywhere. So whatever question we had done previously, same question you put angular, they become question of this. Yes or no? Now we shall move on and see the equations of motion. Now remember, these equations of motion are only valid when the acceleration is constant alpha. Please note them down first, understand them, and then you can write them on your own. Do not write it from the whiteboard, see it once, and then you should be able to write them on your own. What will be the first equation of motion for constant angular acceleration? Yes. What would the first one?
V is equals to U plus 8.
There is no V, there is no U, there is no A here. Try again. There is no V, there is no U, there is no A here. So, what do we write next? Omega 2 is equal to omega 1 plus alpha t. Now remember, whenever we are writing this equation, whenever we wrote the equations there, we use the sign convention. Positive, negative, positive, negative. Here also we must choose the sign convention. And what is the sign convention here? Anti-clockwise is taken as positive and clockwise is taken as negative. Do we understand this? Anti-clockwise is positive and clockwise is negative. Do not forget this sign convention. Okay, that was the first equation. What would be the second equation? Delta theta will be equal to omega 1 t plus half alpha t square. What is delta theta here? Delta theta here is angular displacement. Everyone understands this? Yes or no? Omega 1 is the initial angular velocity. Alpha is the angular acceleration and t is the time. What is the third equation? Omega 2 square will be equal to omega 1 square plus 2 times alpha into delta theta. Do we understand this? Yes or no? No, yes. What is the fourth equation? If I write the fourth equation, that will be displacement. Angular displacement in the nth second will be omega 1 plus alpha by 2 into 2n minus 1. Do we understand this? Are we able to understand this? What are we writing? Yes or no? No or yes? It is exactly similar to what we had done in the previous thing. Now, on the right hand side, I will write the other equations which we have already done. What is the first equation that we had done? V is equal to U plus AT. We remember this equation, yes or no, so that you can compare them. Second equation, delta R, displacement is UT plus half AT square. Third equation.
V square is
Yes.
minus U square minus 2A.
Yes, V square is equal to U square plus 2 times A into delta R. The fourth one is displacement in the nth second will be equal to U plus A by 2 into 2n minus 1. I'll give you 2 minutes to write these equations. Let me know once you are done, bacha.
Done, sir.
Okay. Then let us move on and solve some questions. I hope you would understand and tell me the answer for this one. This is the first question coming for you. And here is the question. A wheel is at rest its angular velocity increases uniformly and it becomes 60 radians per second after 5 seconds. What is the total angular displacement? I'll give you 2 minutes to solve this.
Sir, answer C.
Answer is
Answer C.
C.
Option C.
No,
Yes, sir.
C is not the correct answer, beta.
Option C.
Option D. 1, 2, 3, 4. Tell me that way. A, B, C, D, I can't understand. Option 4. Yes, option 4 is the right option. And how did we get it? Have everyone got the option 4? So, the wheel is at rest. That means your value of omega 1 is 0. Yes or no? It becomes 60 radians per second. So that is omega 2. This is time. And they have asked us the value of delta theta. So first of all, what we'll do is we'll find the value of alpha. Angular acceleration is constant because it is given as it is increasing uniformly. So how do you find the value of alpha? Everyone knows this? Omega 2 minus omega 1 divided by t. Do we understand this, bacha? I put the values and I get the value of alpha. It will be 12 radians per second square. Once I get the value of alpha, now you can use any formula. I will use this formula. Delta theta is equal to omega 1 into t plus half into alpha into t square. Omega is 0. Omega 1 is 0. It starts from rest. Value of alpha I have already calculated 12. Time is given as 5. I think you can calculate the value. And I think the answer is coming as 150 radians. Is it coming? Yes or no? Okay. How many of you got the answer? Well done. Chalo. Can you move on to the next question, bacha?
Yes, sir.
Remember, whatever
Yes,
questions
sir.
we are doing now here, the same questions could be made for linear motion. The only thing is here it is alpha, there it is a, everything is angular. Do we understand this? Okay. This is the next question. And I'll give you 2 minutes. A wheel initially as it's at rest is rotated with a uniform angular acceleration. The wheel rotates through an angle theta 1 in the first second and through an additional angle theta 2 in the next 1 second. What is the ratio of theta 2 is to theta 1? I'll give you 2 minutes to solve this. Shall I help you, bacha? Anyone got any answer?
A, sir.
A.
E, sir.
Yes, sir.
Someone got A, someone got B. Anyone got C? No one. A and B both are not correct. Okay, so how are you supposed to do this?
Answer is C, sir.
Answer is C. The wheel initially starts from rest, so the value of omega 1 is 0. Acceleration, uniform angular acceleration. It rotates to an angle theta 1 in the first second. So this is the displacement in the first second. Displacement in the first second. I can put the values omega 1 plus alpha by 2 into 2n minus 1. Do we understand this? From there, I can find out the displacement in the first second. How much it is coming? It will come as alpha by 2. Yes or no? Then I can find what is given. And it turns to an additional theta 2 in the next 1 second. So that is which second? That is the second second. Yes or no? So what is the displacement in the second second? Omega 1, that is 0. Don't worry about that. Plus alpha by 2 into 2n minus 1. The value of n is 2. So what value will I get here? I will get 3 alpha by 2. Yes or no? Then you can find the ratio of theta 2 to theta 1. And the correct answer that you will get will be option C. How many of you got this answer, option C? Okay. But no one said anything. Remember, trust your instinct. Whatever you are doing may be correct. Don't worry about what others are saying. Can I give you the next question? This question has come in one of the previous year engineering exams as well as in JEE 2 or 3 times. So let us see if you can do this. The wheel of a car is rotating at the rate of 1200 revolutions per minute. This question is done for a very specific purpose. 1200 revolutions per minute. On pressing the acceleration for 10 seconds, it starts rotating at 4500 revolutions per minute. What is the angular acceleration of the wheel? I'll give you 2 minutes to think about it. Shall I do it? Shall I do it, bacha? Remember, this question was given for a very specific reason, for you to understand that sometimes, many times, in fact, all the time when this question on rotation or rotation will come, it will be given not in radians per second, but revolutions per minute. Now, when it is given the question in terms of revolutions per minute, you have to understand that you will have to convert it into radians per second. How do you convert revolutions per minute into radians per second? So you remember 1 RPM, RPM means revolution per minute. In one revolution, it rotates 2 pi, and 1 minute consists of 60 seconds. So 1 RPM is 2 pi by 60 radians per second. Do we understand this? Remember this. Now, this is the value of omega 1. This is the value of omega 2. So I can find out the value of omega 1 is 1200 revolutions per minute. So I multiply it by 2 pi and divide it by 60. So that will be your omega. So it will come as how much? 240 pi radians per second. Yes or no? Okay. Then I find the value of omega 2. That will be equal to 4500 multiplied by 2 pi by 60. This goes once. This goes 3 times. And this goes 150 times. Have I done it correctly? It is coming as 150. Have I
Sir,
done?
40 pi, sir. Omega 1.
Yes, beta. I've. Oh, it is 2.
40 is 40, sir.
I've done it wrongly, I guess. Let me do it again. 4500 multiplied by 2.
Sir, omega 1 value is 240 pi. 40 pi, sir.
Oh, yes. I have done it wrongly, I guess, right? This is 20. This is 40 pi. Yes, sorry. That was a mistake, not this one. Okay. This one goes away. This goes 3 times. This goes 150 times. So I get 150 pi radians per second. Do we understand this? From here, I can calculate the value of alpha. Alpha will be omega 2 minus omega 1 divided by t. So 150 minus 40 divided by time is 10 seconds. So it becomes, I think, 110 pi. No, 11 pi, yes? Isn't it? 110, it becomes 11 pi.
Yes, sir.
Now 11 pi radians per second. Now again, there is a small conversion that you will have to make. And this is for this conversion only this question was given to you, so that you are able to make that conversion. What is that conversion? Now the answer is given in radians per second square. This answer is not matching and this answer is not matching. Oh, sorry. This answer is not matching and this answer is not matching. A and C are not matching in radians per second square. So we'll have to convert it into degrees per second square. How do you convert it into degrees per second square? Radians per second square into degrees per second square. Anyone? How do you convert radians per second square into degrees per second square? So I have to convert 11 pi. This is in radians. I have to convert it into degrees. So what will I do? I will multiply it by 180 and divide it by pi. Do we understand this? 180 degrees is pi radians. Pi radians is 180 degrees. So 11 pi radians will be 11 pi multiplied by 180 by pi. So it becomes 11 multiplied by 180 and the correct answer is 880 degrees per second square. Do we understand this? No, sorry, not 880. It will be 980. 1980, not 1880. 1980. Do we understand this? So we have seen two conversions here. One is the conversion of RPM to radians per second. The other is from radians per second into degrees per second square. Do we understand this, everyone? Two conversions, and these questions can come in these. Degrees per second square will not come, so the second conversion may not be of so importance, but you must remember two golden points here. One is this, and you must remember pi radians is 180 degrees. Do we remember both of these equations? To remember this, you should be able to convert this. Can I give the last question for today? Let's see who gets this one. Remember, whatever we have done in motion in 1D, the same thing comes over here. We understand this? Let's see who can give me this one. As a part of maintenance inspection, and if you become engineers, you will be doing a lot of maintenance inspection. The compressor of a jet engine is made to spin according to the graph as shown in the figure. The number of revolutions per minute, remember revolutions per minute, made by the compressor during the test is how much revolutions the compressor is making during the test. How many revolutions it is making during the test. When you get these type of questions, stay happy. You should be able to do them if you just remember simple things. How many revolutions is the compressor going to make? So what is given to you is RPM versus T graph. The units are different. Basically, what they have given you is omega versus T graph. Do we understand this, bacha? Remember, area under velocity time graph gives us displacement. So area under omega time graph will give us angular displacement. Do we understand this? Don't worry, in the next class we will write all these things down. Right now, just do this question. I hope you can do this question. Yes or no? No, yes. 2 minutes you have. Shall I do it for you, bacha? Shall I do it for you?
Option D, sir.
Option D, sir. That is absolutely correct, sir. What you got to do is you just need to find out the area of this graph. Yes or no, my dear friends? Now remember, you can find out the area breaking it into triangle, rectangle, and a triangle. But the better way is, remember, you will have to save time. Do we understand that? You will have to save time. So straight away put the formula of trapezium. Do you know the area of a trapezium? Half into sum of parallel sides. This is one parallel side and this one is the other parallel side. Sum of parallel side is half the total नीचे वाला side is 5 and the ऊपर वाला side is 2.5, sum of parallel sides multiplied by the distance between the sides, which is 3000. So remember the area of a trapezium, so that you don't have to break it up into triangle, triangle, and a rectangle. It will take time. If you find out the area of triangle, then rectangle, then triangle, you can easily find out the area of the trapezium. Everyone understands this? Yes or no? No, yes? In the next class, we will go ahead and complete this uniform circular motion. This circular motion wala part. There are some points that we'll have to still study. There are some more questions that we need to do. You already have the sheet of motion in 2D. In that sheet of motion in 2D, you have the exercise on circular motion. Have you seen that sheet? Please solve the question from that sheet. Whatever question comes in the exam will be from that sheet. Take care. I'll see you tomorrow in the next class. Bye bye. God bless you all. Everyone understood this? Similar questions.